Welcome back to the deep dive, where we cut through the noise and get straight to the insights that truly matter. It feels like we can't go a single day without hearing about generative AI.
It's everywhere, absolutely.
But have you ever paused to consider what people are actually doing with it in their daily lives beyond the sensational headlines? Because here's a fact that truly puts things into perspective, and frankly, it's kind of a bombshell.
Oh.
Nearly 40% of Americans are already reporting that they use generative AI, either at home or at work.
40%. Wow.
Think about that for a moment. That's an adoption rate that's actually outpacing the early diffusion of personal computers and even the internet. It's an astonishing pace.
That's incredible, actually. Faster than the internet.
Right. And it immediately begs the crucial question for all of us. What are people genuinely achieving with this incredibly powerful new technology? Okay, so let's unpack this. Today, we're embarking on a focused deep dive into a truly groundbreaking research paper from Microsoft Research. It's titled, Working with AI, Measuring the Occupational Implications of Generative AI.
A really important one.
Consider this your ultimate shortcut to understanding how AI is really reshaping the workforce. Not just in theoretical models or, speculative predictions, but through the lens of actual user behavior.
And what's truly fascinating here, and what really sets this study apart, is precisely what you just touched on. This isn't another predictive model or a survey asking people what they might do.
Right, not speculation.
Exactly. This study provides real-world empirical evidence. It's built on the analysis of an incredible data set. 200,000 anonymized conversations from Microsoft Bing Copilot.
200,000, that's huge.
It is. That's a massive, kind of unfiltered window into genuine user interaction, offering us a granular, almost microscopic view of how people are engaging with AI right now, rather than just what we speculate it could do for them.
That real-world data is absolutely key. So our core source for this deep dive is this single, extraordinarily rich research paper. It allows us to conduct a really focused, almost instructor-led exploration, guiding you step by step through its remarkable findings.
Yeah, we can really dig in.
At its heart, the paper's mission is crystal clear: to understand which specific work activities are being most influenced by AI, and by extension, which occupations are truly feeling that impact, both directly and indirectly. It's about moving beyond the abstract and into the concrete reality of AI's footprint. So let's begin with a foundational concept that this paper robustly argues for. The idea of generative AI is what economists call a general-purpose technology, or GPT.
Right, GPT. Not the same as the AI model GPT, confusingly enough.
Yeah, good point. General-purpose technology. Now, historically, we've only had a handful of these truly transformative GPTs. Think about the steam engine, or the introduction of electricity, or even the personal computer.
Game changers.
Exactly. These weren't just incremental improvements, they were fundamental game changers. They didn't just make one industry better, they fundamentally reshaped every sector of the economy, driving massive, unprecedented economic growth across the board. They are technologies that keep accelerating their impact with each new advancement, creating entirely new ways of working and living.
Okay.
So the big question, and the paper makes a strong case for it, is why is generative AI being hailed as the next candidate GPT in this exclusive club? What makes its potential for broad transformative impact so similar to these giants of history?
That's a critical question, and the paper offers a pretty compelling answer. Generative AI possesses this unique and powerful capability. It can improve or significantly speed up a remarkably diverse range of tasks.
It's not just for one thing.
Precisely. This isn't about a niche tool that solves one specific problem. We're talking about its ability to impact areas as varied as, say, medical diagnosis, where AI can quickly sift through vast amounts of patient data, scientific literature, treatment protocols, you name it, to assist doctors.
Right.
Or, on the completely different end of the spectrum, consider software development. It can assist with everything from generating initial code snippets to debugging really complex programs.
Yeah, code generation is huge now.
It is, and this incredible versatility, this inherent adaptability to fundamentally different domains is what truly sets it apart. It's not just another cool gadget, it's a foundational capability that can be applied, well, pretty much everywhere. And as we pointed out right at the top of our deep dive, this inherent versatility is directly reflected in its astounding adoption rate. That statistic, nearly 40% of Americans already using generative AI, isn't just a quirky data point.
No, it's real.
It's tangible, undeniable evidence of how rapidly this technology is embedding itself into the fabric of our daily lives and our professional routines. It's moving faster than even the personal computer and the internet did in their early days, which really underscores its profound, widespread potential.
So, for you, our listener, understanding this isn't merely about keeping up with the latest technological buzz. It's about grasping a fundamental economic and societal shift that is happening in real time.
It really is a shift.
This isn't just about a new tool appearing on the market. It's about a foundational technology actively changing how all work gets done. Whether you're a doctor analyzing a complex case, a programmer wrestling with lines of code, or even just someone trying to efficiently plan your week or organize your thoughts. Generative AI is subtly, or maybe not so subtly, altering your workflow. Now, let's talk about the very bedrock of this entire study, the Microsoft Bing Copilot dataset. The researchers meticulously analyzed an enormous collection of 200,000 conversations.
That's a lot of data.
It really is.
Yeah.
And these conversations were fully anonymized and privacy scrubbed, meaning every piece of personally identifiable information was removed, making them safe for analysis.
Crucial point.
They were drawn from Microsoft Bing Copilot, which, as a quick note, is now simply called Microsoft Copilot, and sampled over a significant 9-month period in 2024, specifically focusing on U.S. usage.
Right, US-based.
The real power here lies in the phrase real-world usage. This isn't a theoretical exercise or a lab experiment or even a self-reported survey where people might speculate about what they would do.
No, this is what's actually happening.
This is an unfiltered, unvarnished snapshot of what millions of people are actually doing with generative AI day in and day out.
Precisely. And the rigor involved in this data collection truly cannot be overstated. Beyond the privacy scrubbing, the conversations were representatively sampled.
What does that mean exactly, representatively sampled?
It means they deliberately aimed for a view that accurately reflects the broad usage patterns across the U.S. workforce, avoiding skew towards any particular type of user or industry. So it's not just tech workers, for instance.
Gotcha. A balanced view.
Exactly. The paper even distinguishes between two distinct sub-data sets within this larger pool. There's the Copilot Uniform dataset, which gives us that broad representative view of typical usage. And then there's the Copilot Thumbs dataset.
Thumbs, like thumbs up, thumbs down.
Exactly that. It's specifically curated to include conversations where users provided explicit feedback, those thumbs up or thumbs down reactions. This user feedback is incredibly valuable for measuring perceived success. However, and this is where their methodological sophistication really shines, they also openly acknowledge a critical challenge with the Copilot Thumbs data.
Which is?
User feedback, while useful, isn't always perfectly representative. Think about it. Some users might be more inclined to give feedback than others, or certain tasks might naturally elicit more reactions, positive or negative.
Right, so it could be biased.
It could be. And this raises an important question for any researcher. How do you measure success accurately when you're dealing with real-world private conversations where explicit feedback might be biased or incomplete?
So how do they handle that?
This is precisely why they went a step further. They supplemented the user-provided feedback with an independent AI classifier.
Using AI to check the AI.
Pretty much. A smaller, specialized, large language model designed to objectively assess task completion based on the conversation's content itself. This innovative approach provides a much more robust and objective measure of how effective the AI really is, cleverly working around the inherent limitations of relying solely on human-provided ratings.
That's smart.
It's a fantastic example of using AI to understand AI.
That brings us to what the paper identifies as a truly crucial key insight for understanding AI's real-world impact. They argue that to truly grasp what's happening, you need to dissect every AI conversation by looking at two distinct but interconnected elements, the user goal and the AI action.
Yeah, this distinction is fundamental to their whole analysis.
Can you break down what each of those means and, more importantly, illuminate why this distinction is so profoundly important for their analysis?
Absolutely. Think of it like this. The user goal is exactly what it sounds like. It's the underlying task or objective the human user is trying to accomplish by interacting with the AI.
What the person wants help with.
Exactly. It's the user's intention. For instance, if you type into Copilot, help me write a concise email to my team about our new project timeline, Your user goal would be classified as something like write material for artistic or commercial purposes, or maybe draft internal communications. You want to produce that specific email. The AI action, on the other hand, is the specific task or function that the AI itself performs within that conversation.
What the AI actually does.
Right. It's what the AI actually does in response to your prompt. So following your email example, the AI action might be classified as develop news, entertainment, or artistic content as it actively generates the text, or perhaps even provide general assistance to others as it fulfills your request for help. Another vivid example the paper uses is a user trying to resolve computer issues. That's the user goal. The AI's action might be providing technical support by offering troubleshooting steps or diagnostic questions. They are distinct yet deeply complementary facets of the same interaction. Now, here's where the nuance truly becomes fascinating. Sometimes these two, the user goal and the AI action, can be quite aligned. If you ask Copilot to generate a creative story about a dragon, both your goal and the AI's action might fall under the umbrella of developing content.
They match up.
They're in perfect sync. However, and this is one of the study's most surprising revelations, they found that in a significant 40% of conversations, the sets of identified intermediate work activities for the user goal and the AI action were completely disjoint.
Wow, 40%. That's huge. Completely different activities.
Completely disjoint sets of activities, 40%. That means the AI was often doing something fundamentally different in terms of its core activity classification from what the user was ultimately trying to achieve with the AI's output.
Huh. So why is that distinction so important then?
Well, when we step back and connect this to the broader picture, this critical distinction helps us move far beyond simplistic automation versus augmentation debates.
Ah, right. Is it replacing or helping?
Exactly. Instead of broadly asserting that AI either automates or augments, this method allows them to separately and precisely measure what the AI is helping the human achieve, the user goal part, and what the AI is doing itself, the AI action part. This provides a much more precise and sophisticated understanding of AI's truly multifaceted role in the contemporary workforce.
That makes perfect sense. And that 40% disjoint rate is genuinely eye-opening. So to systematically classify these incredibly diverse user goals and AI actions, the paper wisely leverages a well-established and highly respected resource.
Yeah.
The OneNet database.
Yeah, OneNet is the standard, really.
For those of us who might not be intimately familiar with it, what exactly is a OneNet and why is it such an important foundational tool for this kind of detailed occupational analysis?
OneNet, which is short for the Occupational Information Network, is essentially the authoritative, comprehensive database for occupational information in the United States. It's developed and maintained under the U.S. Department of Labor.
National government resource.
Right. And it's critical because it provides a standardized, deeply hierarchical way to break down occupations into their constituent work activities. Think of it like building blocks.
Okay.
At the very granular level, you have thousands of specific tasks, things like process loan applications or diagnose patient symptoms. These specific tasks then roll up into broader, detailed work activities, which in turn feed into intermediate work activities, or IWAs. And finally, at the very top, you have the most general categories, the generalized work activities, or GWAs.
So it goes from super specific to very broad.
Exactly. And the beauty of this study and why it focuses on the IWAs is that there are 332 distinct categories of these intermediate work activities.
332 IWAs.
They are general enough to apply across many different occupations, making them incredibly versatile for this kind of analysis. For example, the IWA Analyze Market or Industry Conditions isn't exclusive to market research analysts. It applies equally to financial analysts, business development managers, even political scientists.
Right, cuts across different jobs.
Precisely. This level of granularity is perfect because it allows the researchers to understand broad AI applicability without getting bogged down in the minutiae of hyper-specific niche tasks. Now, to briefly dive into their methodology without getting lost in the weeds, they employed a sophisticated AI-powered classification system.
Using AI again.
Yep. They used a GPT-4o-based large language model pipeline to identify these IWAs for both user goals and AI actions within each conversation. This wasn't some basic keyword search. It involved a powerful AI analyzing the complex natural language of each interaction.
So it understood the context.
Right. And to ensure they were on the right track, they meticulously validated their AI classifiers with human annotators. These human reviewers were blind to the AI's output.
Meaning they didn't know what the AI said.
Exactly. They didn't know what the LLM had predicted, which helped remove any potential bias and ensure the accuracy and reliability of the classifications. They deliberately chose to focus on IWAs over the more numerous and often redundant tasks. Imagine there are over 18,000 specific tasks in one ET compared to just 332 IWAs.
Way too many tasks to handle reliably, I guess.
Exactly. It was a pragmatic choice for accuracy and reliability. It's incredibly difficult, for instance, to distinguish between subtle variations of programming tasks for different types of developers without knowing the user's specific job title. But an IWA like Program Computer Systems or Production Equipment is clear, broadly applicable.
And lets them see the impact across all jobs that do that kind of programming.
Precisely, without having to guess the user's specific job. Finally, because a single conversation might touch upon multiple IWAs.
Like you might ask for information and ask it to write something.
Exactly. So they used an activity share metric. This effectively means that if a conversation was relevant to 3 different IWAs, an equal fraction of its relevance would be allocated to each. It ensures a balanced and comprehensive view when a conversation spans several different work activities. It's a very robust way to measure the actual spread of AI usage.
So with all this incredibly detailed classification of what's happening in these conversations, the paper then introduces its core metric, the AI applicability score for each occupation. This is truly where the rubber meets the road, where the data starts to reveal what matters to you, our listener.
Yeah, this score is the key output.
So what exactly does this score mean? How do they actually measure the potential impact of generative AI on an occupation and translate it into a single meaningful score?
Okay, so a higher AI applicability score fundamentally signals that an occupation is more likely to be influenced or transformed by generative AI. It's a comprehensive measure, not a simple sum, built upon 3 crucial components, each adding a layer of depth.
3 components, what are they?
First, there's usage, which they quantify as activity share. This component asks, is AI actually being used for the work activities that are relevant to a specific occupation?
Is it showing up in the conversations for that kind of work?
Pretty much. To be considered covered, meaning there's significant AI engagement, an IWA needed to appear with at least a 0.05% activity share in the Copilot data.
0.05%. That sounds tiny.
It sounds small, but it roughly translates to an IWA showing up in maybe 100 to 300 conversations out of their massive 200,000 conversation sample. This threshold cleverly filters out rare or incidental AI usage, focusing instead on activities where there's consistent, non-trivial engagement.
Okay, so it weeds out the random one-offs. That makes sense. What's next?
Second, we consider success measured by completion rate. It's not enough for AI to simply be used, it also needs to be helpful and effective.
Did it actually do the job?
Right. This component rigorously measures how successfully those activities are assisted or performed by the AI. They utilize 2 measures for this. The explicit user thumbs-up-down feedback from the Copilot Thumbs dataset.
Capturing user satisfaction.
Exactly. And as we discussed, they also leverage that objective AI-powered task completion classifier, which impartially assesses if the user's stated task was successfully completed within the conversation. So both subjective and objective measures of success.
Okay, usage and success. What's the third component?
And third, there's scope or impact breadth. This is absolutely crucial for distinguishing between superficial assistance and deep transformative integration.
Scope. Like how much of the task it helps with.
Exactly. This component measures the extent to which the AI's demonstrated capability in a conversation truly translates to the full range or scope of work within that specific IWA. It's assessed on a 6-point scale, from none to complete.
Can you give an example?
Sure. If you ask Copilot to proofread a single sentence, that's a very small fraction of the broader IWA editing written materials. But if it helps you brainstorm, outline, draft, and restructure an entire comprehensive report, that demonstrates a much broader scope of impact within that same activity. It's about depth, not just frequency. So these 3 powerful components, usage, success, and scope, aren't just simply added up. They're meticulously combined using OneNet's internal metrics for task relevance and importance for each job.
So how important that task is for that specific job matters too.
Precisely. Think of it like a carefully weighted average, where activities that are more central or important to a given job carry more weight in the final score. This complex aggregation leads to a specific score for user goals and another for AI actions, which are then averaged to produce the final, incredibly robust AI applicability score for each occupation.
This is where it gets truly illuminating, I think. This applicability score provides a relative comparison across occupations, and that's a critical distinction.
Absolutely critical.
It deliberately sidesteps the pitfalls of making absolute impact claims that we so often see in other studies. You know, those headlines that confidently declare X% of the workforce will be impacted.
Yeah, those numbers can be all over the place.
Right. The paper actually illustrates this beautifully by showing how wildly absolute percentages of the impacted workforce can swing just based on an arbitrary threshold you choose for what qualifies as impacted.
Yeah.
So they aren't trying to give us a single potentially misleading number about job losses or gains.
No, it's much smarter than that.
Instead, they're providing something far more meaningful, a robust and nuanced framework that tells us who is more or less affected relative to others, offering a much more actionable and less speculative comparison across diverse occupations. It's a remarkably thoughtful approach to a complex and, frankly, often emotionally charged issue. Now let's zoom out to the highest level of detail available in that hierarchy, the generalized work activities, or GWAs.
The big bucket.
Exactly. These are those very broad categories like thinking creatively or performing general physical activities. What's the big picture here? When they looked at how Copilot is being used at this macro level, what did the data tell us about its footprint compared to the overall U.S. workforce?
When we examine the high-level patterns, it presents a fascinating bird's-eye view of generative AI's current sweet spot and also its clear limitations. You can imagine looking at a chart where some bars are much shorter for Copilot usage than for the overall workforce, and others are much taller.
So where is it underrepresented? Where is Copilot not being used as much as you'd expect based on the workforce?
Okay, first, let's consider where Copilot usage is underrepresented. These are activities where the share of the general workforce engaged in them substantially outweighs Copilot usage. And, quite predictably, these align almost perfectly with tasks that an LLM chatbot is simply not designed for.
Physical stuff, right?
Exactly. We're talking about tangible, physical activities, things like handling and moving objects or performing general physical activities. You're simply not going to use Copilot to lift a heavy box or run a marathon, and the data confirms that.
Makes sense.
Then there are activities related to monitoring processes or physical environments, such as monitoring processes, materials, or surroundings, and inspecting equipment, structures, or materials. And finally, direct guidance of people or machines, like controlling machines and processes, or guiding, directing, and motivating subordinates.
Okay.
For you, the listener, the clear takeaway here is that AI, at least in its current LLM form, isn't performing manual labor, nor is it directly managing complex physical systems or operations in the real world. Its domain is not the physical realm. Conversely, we observe where Copilot is dramatically overrepresented. These are activities that show up far more frequently in the Copilot data than in the overall workforce.
And this is where it shines.
This is where generative AI truly excels, aligning perfectly with what we broadly term knowledge work.
Okay, like what?
These overrepresented GWAs include getting information, interpreting the meaning of information for others, thinking creatively, updating and using relevant knowledge, and working with computers.
Like information, ideas, computers.
Exactly. The takeaway for our listeners from this clear pattern is a strong confirmation. Generative AI's strength lies squarely in tasks concerning ideas and information. It's about synthesizing, interpreting, and generating knowledge. It's about facilitating creative problem solving. And it's about leveraging digital tools for cognitive work. This powerfully reinforces what many other analyses have also shown. It is an incredibly potent tool for the mind, for anyone engaged in informational or intellectual pursuits. And when we further dissect the data to look at the differences between what the AI does, AI actions, versus what the user wants to achieve, user goals, at this high GWA level, even more nuanced insights emerge.
Okay, what differences do we see there?
We find that AI is significantly more prevalent as an action in areas related to providing service to the user and facilitating communication.
So the AI is doing the service and communication part more often.
Seems like it. This includes GWAs like assisting and caring for others, providing consultation and advice to others, coaching and developing others, and training and teaching others. Also high on the AI action side are external and internal communication activities like communicating with people outside the organization and communicating with supervisors, peers, or subordinates. The AI is actively generating the output for these. In stark contrast, the GWAs that are more prevalent as a user goal, what people are trying to achieve through the AI, are predominantly the higher level, more strategic knowledge work activities.
Things the user wants help executing.
Exactly. These include getting information, thinking creatively, making decisions and solving problems, and analyzing data or information.
So putting it together.
Stepping back for a moment, the broader implication here is that people are largely turning to Copilot to help them execute the foundational aspects of knowledge work activities. Meanwhile, the AI itself is often acting as a highly sophisticated digital assistant, diligently gathering, explaining, and communicating information back to the user. It's a beautifully complementary relationship, with the AI serving as an invaluable support system for a wide array of cognitive and communicative tasks.
That GWA overview gives us the broad strokes, painting a compelling, high-level picture. Now let's get much more specific and drill down into the intermediate work activities, or IWAs, that 332 detailed categories.
Getting into the nitty-gritty.
Exactly. When they looked at the top results, what were the most common things people were asking Copilot to help them with? What were those primary user goals people were bringing to the AI?
When we examine the detailed list of top user goals, it paints a very clear picture of how people are leveraging Copilot day to day. We can see these common activities generally falling into three broad, powerful categories.
What's the first one?
First, information gathering is absolutely dominant. This category includes IWS, like gather information from various sources, obtain information about goods or services, maintain knowledge in area of expertise, and read documents or materials.
So basically, using it as a super researcher.
Pretty much. This tells us that people are instinctively turning to AI as their primary research assistant, a lightning-fast way to get up to speed on a new topic, retrieve specific details, or synthesize vast amounts of data quickly. It's like having a hyper-efficient librarian or research associate on demand.
Okay, information gathering is number one. What's next?
Second, we see a massive reliance on AI for content creation and editing.
Writing and designing stuff.
Exactly. This covers critical IWAs such as develop news, entertainment, or artistic content, write material for artistic or commercial purposes, create visual designs or displays, and edit written materials or documents.
Right. Drafting emails, reports, maybe even code?
All of the above. Whether it's drafting a tricky email, brainstorming ideas for a new marketing campaign, or refining a complex report for clarity and impact, users are heavily leveraging Copilot to handle the often time-consuming heavy lifting of writing and design. It's a profound shift in how creative and administrative content is produced.
Right. Info gathering, content creation.
Mhm.
What's the third big category for user goals?
And third, communication emerges as a major user goal. IWAs like provide information or assistance to the public, provide general assistance to others, explain technical details of products or services, and explain regulations, policies, or procedures are all very common.
So helping people explain things or interact with others.
Right. People are clearly using AI to help them formulate their messages, to clarify complex topics for others, or to prepare for crucial interactions where they need to convey information effectively and concisely.
So this insight truly raises an important question for you, our listener.
Hmm.
Are you currently using AI for these very tasks? It seems incredibly clear that Copilot, and by extension other similar generative AI models, are proving particularly adept at being an information conduit and a versatile content assistant, fundamentally helping people perform these essential knowledge-based and communication-heavy work activities more efficiently than ever before. And what about the flip side of that coin? We've explored what users want to achieve. What tasks is the AI actually performing in these conversations? What do the top AI actions look like from its perspective?
The top AI actions tell a complementary yet distinct story. The AI predominantly takes on a distinct service role in these interactions.
A service role, how so?
The verbs associated with its most common actions really underscore this. It responds, provides, presents, and assists. It's a very active, supportive posture.
Okay, so what specific actions fall under that?
More specifically, the leading AI actions can also be grouped into three distinct categories, similar to the user goals but with a different focus. First, gathering and reporting information, which includes actions like gather information from various sources, prepare informational or instructional materials, and develop news, entertainment, or artistic content.
So it's finding and packaging the info.
Exactly. Here, the AI is proactively finding, structuring, and sometimes generating information for the user. Second, explaining information, covering IWAs such as present research or technical information, explain technical details of products or services, and explain regulations, policies, or procedures.
Making complex stuff understandable.
Right. This means the AI is frequently taking complex topics and distilling them into more understandable formats, effectively acting as an explainer or tutor. And third, communicating directly with the user, encompassing actions like respond to customer problems or inquiries, provide general assistance to others, provide information to clients' customers, and advise others on products or services.
So directly answering questions, giving advice.
In these instances, the AI is directly engaging with the user, delivering requested information or offering guidance. So when we put the user goals and AI actions together, the picture clarifies beautifully. Humans are leveraging AI to gather, process, and ultimately disseminate information for their own tasks.
They're driving.
In return, the AI is actively helping them by gathering, explaining, and communicating that critical information to the user. It's a true partnership, often with the AI functioning as the powerful information and communication engine behind the human's broader cognitive or professional task.
Now, here's where it gets truly fascinating and perhaps a little counterintuitive. You've described how the user goals and AI actions are often complementary, but the paper also highlights a surprising finding about the disjoint nature of these two sets of activities.
Ah, yes, the 40% disjoint finding again.
They found that in a significant 40% of conversations, the sets of user goal and AI action IWAs were completely disjoint. That's a remarkable figure, suggesting that the AI is often performing a task that is fundamentally different from what the user is trying to achieve with its output. Can you elaborate on that asymmetry and what it really means for how we think about AI in the workplace?
This asymmetry is one of the most compelling and nuanced insights to emerge from the study. The researchers highlight it powerfully by showing extreme ratios between user goal and AI action activity shares for certain IWAs. It reveals that AI isn't just doing exactly what you asked for in a direct one-to-one translation.
Okay, so where does it assist more than perform?
On one hand, you have activities where the AI is overwhelmingly more likely to assist a user rather than perform the activity itself. This means the user goal is far more prevalent than the AI action. These tend to be activities with significant physical components or those requiring direct interaction with external real-world entities.
Like the physical stuff we mentioned earlier.
Exactly. For instance, the IWA perform athletic activities showed the user goal was 47 times more prevalent than the AI action.
Right. You don't ask AI to do push-ups for you.
Exactly. You're not asking AI to do your workout for you, of course, but it can absolutely help you plan it or provide guidance on technique or nutrition. Similarly, for tasks like operate office equipment or purchase goods or services, the AI provides information or guidance for the user to perform these tasks in the physical or external world. It's like having a digital assistant giving you detailed instructions for a manual process, empowering you to do it yourself.
Okay, so that's where it assists. Where does it perform more than assist?
On the other hand, there are activities where the AI is much more likely to perform the action itself, even if the user isn't directly trying to be that role. These are activities deeply related to training, coaching, teaching, and advising.
Ah, interesting. Like AI is the teacher.
Precisely. For example, train others on operational procedures was nearly 18 times more prevalent as an AI action than a user goal. In these cases, the AI is actively doing the training or advising, directly providing that expertise to the user. This includes IWOs like coach others, provide general assistance to others, and teach academic or vocational subjects. The AI becomes the active provider of knowledge or guidance.
So to distill that,
Mm.
you're not asking AI to do your workout,
Yeah.
but it can absolutely help you plan it, giving you a detailed training regimen. And crucially, it's actively stepping into roles that have traditionally required direct human expertise in education and guidance, performing those advisory and teaching functions itself. It's not just helping you write an essay. It's capable of teaching you how to write one, or how to operate a piece of machinery by delivering instruction. That truly represents a significant and subtle shift in its perceived and actual role in the modern workplace. Beyond simply understanding what activities are happening, the paper delves even deeper, asking, how helpful is Copilot truly proving to be in these interactions? They explore this by looking at three distinct metrics. User satisfaction, measured by those thumbs up down,
Right, the thumbs data.
objective task completion rates, and what they term the scope of impact. Let's start with user satisfaction. What does that feedback tell us about how users genuinely feel about Copilot's assistance?
The user feedback, specifically the thumbs up down from the Copilot thumbs dataset, offers a direct and unfiltered signal of user satisfaction, and the findings are generally quite positive.
People mostly like it.
Generally, yes. The study reveals that most common IWAs receive over 50% positive feedback, which is a strong indicator that, on the whole, people are finding Copilot genuinely helpful across a broad spectrum of tasks. When we break it down, some specific types of work activities consistently show exceptionally high satisfaction.
Like what? Where is it really hitting the mark?
These include virtually anything involving writing and editing text, such as edit written materials or documents, and write material for artistic or commercial purposes. Users are clearly delighted with AI's ability to help them craft and refine words, whether for professional or personal use.
Okay, writing's a big win?
Another area of consistently high satisfaction is researching information, covering tasks like research healthcare issues, research laws, precedents, or other legal data, and maintain current knowledge in area expertise. People unequivocally value AI as a powerful, rapid research assistant.
Finding info quickly. Got it.
Lastly, tasks related to evaluating or purchasing goods and services also score high, with IWAs like purchase goods or services and evaluate the characteristics, usefulness, or performance of products or technologies receiving strong positive feedback. It speaks to AI's utility in consumer decision-making and planning. In contrast, the study found that work activities involving complex data analysis, such as process digital or online data, calculate financial data, or analyze scientific or applied data.
Number crunching.
Right. Or tasks requiring intricate visual design like create visual designs or displays and arrange displays or decorations tended to receive comparatively lower satisfaction scores.
So it's a fairly clear message to anyone considering using these tools. Copilot seems far more adept at helping you craft words and efficiently find information than it is at crunching intricate numbers or masterfully designing visuals.
That seems to be the pattern.
That's a pretty clear signal for users, really highlighting its current strengths and, perhaps more importantly, its areas of weakness or where a human touch remains indispensable. If you're trying to design a complex logo or conduct a deep statistical analysis, you'll likely still need specialized software or perhaps a skilled human expert.
And to complement that user feedback, which as we discussed, can sometimes be subject to biases.
Right. Not everyone gives feedback.
Exactly. Perhaps not everyone gives feedback, or certain tasks elicit more emotional responses than others. The researchers implemented an objective measure, an AI classifier. They used a smaller, specialized large language model, GPT-4o Mini, to objectively assess task completion.
The AI judging the AI again.
Yep. This model was trained to determine whether the AI successfully completed the user's task in a given conversation. What's compelling is the strong correlation they discovered between these two success metrics.
So the thumbs up matched the AI's assessment.
Pretty much. Positive user feedback, thumbs up, was highly correlated with a high task completion rate. We're talking about a weighted correlation of 0.83 for user goals and 0.76 for AI actions. This indicates that both metrics are largely capturing the same underlying signal of AI success, giving us greater confidence in the findings. When they examined the top and bottom IWAs by this objective completion rate, they observed very similar patterns to the satisfaction data.
Same strengths and weaknesses.
Largely, yes. High completion rates were found for activities involving writing and researching, as well as for advising and explaining IWAs. This powerfully reinforces the idea that AI excels in domains where it can provide structured information, generate text, or transform existing text. Conversely, it continues to show struggle with more deeply analytical or visually creative tasks, which often demand higher-order abstract reasoning or sophisticated aesthetic judgment that current LLMs haven't quite mastered.
And then there's scope. This is about understanding how deeply the AI's capability penetrates into the full breadth of a work activity, not just if it completes a single instance. This gets at the depth of AI's assistance, which feels like a critical piece of the puzzle.
That's absolutely right. Scope delves into the fraction of work within an IWA that the AI demonstrates the ability to assist or perform. As you said, it's measured on that 6-point scale from none to complete.
So what activities had high scope? Where does it help across the whole task?
When they analyzed the data for scope, they found that activities with consistently high impact scope included information gathering, writing, providing information, advising, and explaining. These are the areas where the AI can contribute significantly across a broad range of subtasks within that specific IWA, truly impacting a larger portion of the overall activity. On the flip side, IWAs with low impact scope, mirroring our previous findings, again included complex data analysis and visual design.
Okay, same pattern there.
But it also revealed other important areas where AI has limited scope. interacting directly with external people in complex, nuanced ways.
Ah, the human element.
Exactly. Things like confer with clients to determine needs or order specifications or investigate individuals' background, behavior, or activities. These are tasks that inherently require complex human-to-human interaction, emotional intelligence, and nonverbal cues, areas where an LLM's direct contribution is, quite understandably, inherently limited. A particularly telling finding related to scope is that AI actions consistently have a lower impact scope than user
The
goals.
lower scope for what the AI does versus what the user wants. Why is that?
It raises an important question. Why would AI help users with a broader fraction of their work than it performs directly? The paper suggests that it's because users are typically guiding the AI within a larger, more complex, and human-orchestrated task they are trying to achieve.
So the human sets the big picture, and the AI fills in pieces.
Exactly. The human user maintains the overall strategy and vision, and the AI contributes to specific, impactful pieces of that larger puzzle. What's truly fascinating here, and a genuinely surprising insight, is that the study found that this scope metric is actually a better predictor of what people choose to use AI for than either completion rates or user satisfaction.
Wait, really? Better than whether it worked well or if people liked it.
Yeah, there's a notable correlation of 0.64 between scope and user goal activity share. This implies something profound. It seems users are intuitively drawn to leveraging LLMs for tasks where the LLM can have the broadest overall impact, even if it doesn't always complete them most successfully or lead to the highest immediate satisfaction.
Huh. So people go for the big potential impact, even if it's not perfect yet.
It's as if people recognize the general utility and leverage of the AI's capabilities across a wider swath of a work activity, even if it's not a flawless solution every single time. This reveals a user base that understands the strategic value of AI, not just its tactical execution.
All right, this is what many of you have undoubtedly been waiting for. With all this sophisticated analysis, the distinction between user goals and AI actions, the AI applicability score now for the big reveal. Which jobs are seeing the highest potential for AI impact, and which are least likely to be affected by these specific types of generative AI systems?
The million-dollar question.
This is where the rubber meets the road.
Okay, when we look at the top occupations by AI applicability score, the list might surprise some, but it makes perfect sense once you understand the underlying intermediate work activities.
Lay it on us. Who's at the top?
Right at the very top, interpreters and translators stand out with a staggering 98% of their work activities showing overlap with frequent co-pilot tasks and strong performance in terms of completion and scope.
98%. Wow. Okay. Who else?
Other high-ranking occupations include historians, passenger attendants.
Passenger attendants. Really?
Yep. Sales representatives of services, writers and authors, customer service representatives, and even CNC tool programmers. We can broadly categorize these high-impact roles into a few distinct groups. First, classic knowledge work roles. Think writers, editors, mathematicians, political scientists, and data scientists. These are professions heavily reliant on information processing, analysis, and synthesis.
That makes sense.
Second, we have deeply communication-focused roles, which is a huge category that includes sales representatives, customer service representatives, interpreters, and even broadcast announcers. Their core work revolves around effective human-to-human communication or communicating information.
Right, like the passenger attendants, maybe.
Exactly. And third, we see certain technical roles like CNC tool programmers, where AI can significantly assist with complex coding, design, and optimization aspects of their work. To make this even clearer, let's consider how specific IWAs contribute directly to these high scores. Imagine a dynamic chart that shows the flow of activities.
Connecting the activities to the jobs.
Right. For example, IWAs like provide information to customers, respond to customer inquiries, and provide general assistance to others are massive drivers for the high applicability scores we see in occupations like sales representatives, customer service representatives, and yes, even passenger attendants.
Okay, I see the connection now for passenger attendants. Lots of providing info.
Precisely. You might not have immediately thought of customer service representatives or passenger attendants as being profoundly impacted by large language models, but when you break down their daily work into these core activities of providing information and assisting others, it becomes incredibly clear why AI is so relevant.
Yeah, that breakdown is key.
Similarly, activities such as edit written materials or documents and program computer systems or production equipment are strong underlying forces driving the high applicability for technical writers, editors, and CNC tool programmers. This approach helps us understand the why behind these rankings. It's all about the fundamental activities people perform in their jobs.
And now, for the other end of the spectrum. Which occupations have the lowest AI applicability scores, meaning they're least likely to be directly affected by these specific types of generative AI? What does that landscape look like?
When we examine the occupations with the lowest AI applicability scores, the common themes that emerge are, again, quite intuitive given what large language models fundamentally do. These occupations generally fall into categories that demand a significant physical work.
Hands-on jobs.
Exactly. We're talking about roles like nursing assistants, massage therapists, phlebotomists, and dishwashers. They involve hands-on care, physical manipulation, or direct labor. They also include roles that are primarily focused on operating or monitoring heavy machinery.
Like factory or construction work.
Yeah, things like water treatment plant and system operators, pile driver operators, and industrial truck and tractor operators. And finally, general manual labor roles like roofers and maids and housekeeping cleaners are consistently at the very bottom of the list. Now, it's an incredibly important caveat to stress here. This study is explicitly focused on LLMs, or large language models.
Just the language-based AI.
Right, which are, by their very nature, primarily language-based tools. Stepping back for a moment and connecting this to the broader picture, this doesn't mean that AI won't impact these jobs at all in the future. Far from it.
Good point. Other AI might affect them.
Absolutely. Other types of AI, like advanced robotics for manual labor, sophisticated sensor technology for monitoring complex industrial systems, or even self-driving vehicles for logistics, could certainly have a profound and transformative effect on these very occupations. But LLMs, as a language and information processing tool, are simply less directly relevant to these roles that are dominated by physical demands, highly specialized machinery operation, or hands-on craftsmanship. To provide an even broader perspective, the paper aggregates these individual occupations up to the broader Standard Occupational Classification, or SOC, major groups.
The big job families.
Exactly. These are 22 overarching categories that encompass every occupation in the U.S. workforce. This aggregated view gives us a panoramic understanding of AI's reach. Unsurprisingly, the highest scores are found in sales and related occupations, computer and mathematical occupations, and office and administrative support occupations.
Big chunks of the white-collar workforce.
Pretty much. These represent vast sectors with significant amounts of knowledge work, intricate information processing, and constant communication. We also see high scores in groups with a large human communication and interaction component, such as community and social service occupations and educational instruction and library occupations.
So knowledge work and communication again.
It confirms a consistent and broad trend. The current applicability of generative AI heavily favors knowledge work and communication-oriented roles right across the economy. Conversely, the lowest scores are consistently seen in healthcare support occupations, farming, fishing, and forestry occupations, and construction and extraction occupations.
Physical labor, machinery, outdoors.
Again, these are predominantly roles dominated by physical labor, the operation of specialized machinery, or direct engagement with the natural environment, where LMs have limited direct application in their current form. Finally, the paper also sheds light on an interesting distinction between user goals and AI actions, even at this broader occupation level. This helps us understand where the AI acts as an assistant to the human versus where it truly performs an action that was the user's ultimate goal.
Okay, so where is it more of an assistant?
We see occupations where there's high potential for AI assistance, but less for direct AI performance. These are occupations with significant physical components or roles that involve complex interaction with external entities where the human still needs to be the primary executor of the task. Classic examples include cooks, butchers, and animal breeders.
Right. AI can give a cook a recipe.
Exactly. The AI can provide incredible assistance here, perhaps offering creative recipes for a chef, suggesting optimal cuts of meat for a butcher, or advising on breeding practices for an animal breeder. But it's not actually chopping vegetables, processing meat, or carrying out the breeding itself. It's the recipe consultant, the strategic advisor, not the hands-on laborer.
And where does it perform more? Where does the AI take the lead?
Conversely, there are occupations where there's high potential for AI performance, but less for direct AI assistance as a primary user goal. These are roles heavily focused on teaching, training, managing, or direct communication. For instance, exercise trainers, choreographers, and training and development managers are occupations where the AI itself can directly perform highly supportive roles.
Like being the trainer or teacher itself.
Exactly. It can act as a virtual coach, providing specific exercise routines and motivation, or a digital training manager, outlining learning modules and assessing progress.
So, to echo your earlier analogy, you're seeing AI act as a brilliant recipe consultant for a chef, empowering them with information and ideas, but it's not actually chopping the vegetables or stirring the pot.
Right.
Meanwhile, on the flip side, it is perfectly capable of being a fully functional virtual coach for an exercise enthusiast or a highly efficient HR specialist, providing guidance on complex workplace policies. It really underscores that dual nature of AI's evolving impact. Sometimes it's an invisible helper, other times it takes a more active front and center role, hashtag Gate 8, correlating AI impact with socioeconomic factors. This deep dive has offered us an incredibly unique perspective, providing real-world usage data on AI's current impact. But how does this stack up against the earlier, perhaps more speculative predictions of AI's labor market implications that we've seen circulating in the media and academic circles for years? Do they align?
That's a great question, and the paper directly addresses it by comparing its findings to a notable previous study by Londu et al.
Ah, I think I've seen that one cited.
It gets referenced a lot. This earlier work predicted which tasks would be impacted by LLMs based on judgments made by both human experts and GPT-4. Their core metric, which they called E1, estimated a 50% time savings for certain tasks. Now, when our current study plotted their newly derived AI applicability score against this E1 metric, the results are quite striking.
How so? Did they match up?
What they found was a remarkably strong correlation. There's compelling agreement between those earlier predictions and this study's real-world applicability score.
Really? So the predictions were pretty good.
Surprisingly good, yeah. The employment-weighted correlation is a robust 0.73 at the occupation level, and it jumps to an even more astonishing 0.91 when occupations are aggregated to the broader major group level.
Wow, 0.91 at the group level.
Stepping back for a moment and connecting this to the bigger picture, this is a powerful validation. It suggests that those early predictions about which types of jobs would be affected by LLMs were, for the most part, largely accurate in their general direction, even if they didn't have the real-world usage data we have now. However, while there's strong agreement, there are also some key divergences that are worth noting. Imagine a scatter plot where most points are clustered along a line, but some are off.
Okay, where did they differ?
The points that are above the line, indicating occupations where the current study's applicability score is higher than the earlier predictions, include roles like market research analysts and CNC tool programmers.
So this study sees more impact there than predicted.
Right. This suggests that the early predictions might have underestimated some of the more nuanced or specific ways LLMs could assist in these fields, perhaps missing how much AI could help with data synthesis for analysts, or complex programming for CNC machines. Conversely, some roles like passenger attendants and school bus monitors also appeared higher in this study.
And why might that be?
The researchers suggest that in these cases, their method might be over-extrapolating AI's communication ability to occupations where LLMs may be less profoundly relevant than the sheer volume of communication in those roles might indicate. On the other side, we see occupations where the AI applicability score is lower in the study compared to the earlier predictions.
Where this study sees less impact.
Exactly. These tend to be occupations with low employment numbers or high specialization. Even if LLMs are theoretically well-suited for some of their tasks, those activities might be so rare in the general Copilot dataset that they don't meet the 0.05% usage threshold.
Ah, so not enough people were actually using it for those rare tasks in this dataset.
Precisely. This results in a lower observed applicability score in this real-world usage data. So the predictions might have been spot on about the capability, but the real-world usage data provides a pragmatic filter showing what's actually happening on the ground.
Now for a big question that's on everyone's mind, and one that sparks a lot of debate. Does AI applicability correlate with higher or lower wages? Will AI predominantly affect low-wage jobs, high-wage jobs, or is the impact, as with everything else, more broadly distributed across the economic spectrum?
This is indeed a complex area, and the study offers some genuinely fascinating insights that challenge conventional wisdom. They found a very weak positive correlation between the AI applicability score and the average occupational wage.
Very weak, so not much connection.
Almost none. To be precise, the employment-weighted correlation is only 0.07. Even when they excluded the top 10% of highest-paid workers to remove any extreme outliers, it only slightly increased to 0.13. This is an incredibly subtle relationship, almost negligible.
Oh, why is that? You'd think maybe higher paid knowledge workers would see more impact.
Well, the explanation for this surprisingly low correlation partly lies in the large employment sectors like sales and office and administrative support occupations. These sectors, despite having relatively lower average wages, show surprisingly high AI applicability scores.
Ah, so those big, lower paid but high impact groups pull the average down.
Exactly. These vast groups, even with their moderate wages, are significantly impacted by AI, which essentially flattens the overall correlation between AI applicability and wage. So what this implies for you, the listener, is that unlike some previous automation trends that might have clearly disproportionately affected just low-wage or just high-wage jobs, this doesn't appear to be a clear-cut case of AI strictly impacting one end of the wage spectrum. It's much more nuanced and broadly distributed across the economy, impacting a wide range of job types regardless of their average pay. When we shift our focus to the correlation between AI applicability and education, the picture becomes slightly different, though still nuanced. Here, the study observes a slight positive correlation.
Okay, a bit more of a link with education level.
A bit more, yeah. Occupations that typically require a bachelor's degree or higher tend to have a slightly higher average AI applicability score, with a mean of 0.27 compared to occupations with lower educational requirements, which have a mean of 0.19. This difference is statistically significant, suggesting a noticeable trend. However, it's crucial to understand that it's not a rigid, hard cutoff. There's still substantial overlap across educational requirements in terms of AI applicability.
So it's not just college-educated jobs being affected.
Not at all. Many jobs at all educational levels are seeing some degree of impact. While this difference is more pronounced on the AI action side, meaning AI is performing more tasks in higher educated roles, it generally implies a leaning towards jobs requiring higher education, seeing more applicability.
Why would that be?
It's likely because many knowledge work roles, which generative AI impacts most directly, often require a college degree as a baseline qualification. So, while it's not a direct cause and effect relationship, the types of work that benefit most from LLMs frequently align with roles that demand higher educational qualifications. #tag IAX, discussion, limitations, and future directions.
As we approach the end of our deep dive today, let's bring it all together. What are the most important takeaways from this immense body of research? And what should we, as informed listeners, be mindful of when interpreting these findings about AI's impact on occupations? What are the key nuances of impact that we need to keep firmly in mind?
The primary and perhaps most crucial takeaway is this. While generative AI demonstrates truly significant capabilities that overlap with many, many work activities across countless occupations, it is not performing all of the work activities of any one occupation.
It's not taking over entire jobs.
No. The paper repeatedly emphasizes that AI completion rates, even for tasks it's good at, are not 100%, and the scope of its impact is usually moderate, not complete. So even when there's an overlap, it absolutely does not mean that a work activity is fully automated or that a job is completely replaced. This brings us back to that perennial critical debate: automation versus augmentation.
Replacing versus helping.
Exactly. The paper makes a powerful and necessary point. This data only shows AI usage and its immediate capabilities. It does not show the downstream economic impacts like widespread job loss, changes in wages, or the creation of entirely new roles.
That's a huge caveat. Usage doesn't equal job loss.
Absolutely. It's incredibly tempting to jump to those conclusions, but that would be a significant misinterpretation. Think about the classic ATM example.
Right, the bank tellers.
Exactly. When ATMs were first introduced, they automated a core bank teller task handling deposits and withdrawals. Many predicted mass job losses for tellers. But what actually happened? Banks opened more branches because the cost of operating them decreased, and tellers shifted their focus to more valuable relationship-building tasks, like selling complex financial products or advising on loans.
So automation led to more jobs, but different ones.
In that case, yes. This truly raises an important question for all of us. We have to be exceedingly careful not to conflate a new technological capability with its actual business outcomes or long-term labor market impacts. The technology introduces new possibilities, but how businesses, individuals, and the broader economy adapt to and integrate that capability is a separate, complex, and often unpredictable story that unfolds over years, not months.
That's a vital distinction, and the ATM analogy perfectly illustrates it. No study, no matter how rigorous, is perfect, and this paper openly and commendably acknowledges its own inherent limitations. What are some of the key things they point out that we, as listeners, should be aware of as we absorb these findings?
They detail several crucial limitations that are important context. First, the data is exclusively from one widely used LLM, Microsoft Bing Copilot.
Just the one platform.
Right. While it's massive, other LLMs, like Google's Bard or OpenAI's Claude, have different user bases and usage patterns. For instance, users of Claude are often reported to focus more on programming and mathematical tasks. So this study provides an incredibly valuable slice of the pie, but it's not the whole pie of generative AI usage across all platforms. Second, there's the inherent difficulty in precisely defining work context.
Is it work or play?
Exactly. Imagine a user asking for a new recipe. Is that a professional chef brainstorming a new menu for their high-end restaurant, or simply someone cooking dinner at home for their family? It's hard to definitively determine if a conversation is purely for work or for leisure. This introduces some unavoidable ambiguity into the data. Third, while they made commendable efforts with their completion and scope metrics, conversation data alone cannot fully capture the magnitude of AI's impact.
How much time it saves, for instance.
Right. It shows what is being done and how well, but it doesn't necessarily quantify the full economic effect, like the exact productivity gains or time savings across an entire job. Fourth, their reliance on the WONET database, while a strength, also has its own limitations. It's a US-centric database.
So maybe different results elsewhere.
Potentially, meaning these findings might not directly translate to other countries with different occupational structures. It also may lag behind rapidly evolving workplace activities, as it's a periodically updated database, not real time. And crucially, ONET doesn't capture non-occupational work like tasks done in the home or volunteering, areas where AI is clearly having an impact but aren't reflected here. Finally, they wisely note that decomposing jobs into discrete activities, while standard and necessary, doesn't fully capture the connecting glue.
The connecting glue? What's that?
This refers to the implicit tasks, the essential soft skills, the nuanced strategic thinking, and the human judgment that often contribute the most value to a complex role. You can break down a job into a list of tasks, but you can't always quantify the holistic value a human brings to that role, or the way those tasks interconnect.
So while this is an incredible snapshot, a truly valuable and illuminating piece of research, it's important to remember it's precisely that, a snapshot of one significant piece of a much larger, constantly evolving puzzle.
Exactly.
It's a powerful reminder that the world of work is always in flux, sometimes in ways that are entirely surprising.
Building directly on these limitations, this study, rather than providing definitive answers, really opens up a number of truly fascinating and extremely important future research questions.
Like, what should we be looking at next?
First, how will different occupations actually refactor their work responsibilities in response to AI's capabilities? Just as we discussed with bank tellers shifting from transactional processing to relationship management, how might other jobs fundamentally redefine their core functions and value propositions as AI takes on more tasks? This isn't just about efficiency, it's about reimagining roles. Second, what entirely new occupations will emerge due to AI? Historically, every major technological revolution hasn't just eliminated jobs, it has created entirely new categories of work that were previously unimaginable.
Prompt engineers, AI trainer.
Exactly. What new roles AI prompt engineers, AI ethicists, AI trainers, AI integration specialists will become commonplace as this technology matures and integrates deeper into our economy? This is a critical area for future inquiry and innovation. And third, how will the frontier of AI capabilities continue to shift? Our current measurement of AI applicability is only a snapshot in time.
AI gets better all the time.
It does. As the technology itself rapidly evolves, becoming more multimodal, more reasoning capable, more context-aware, how will its overlap with occupations change over time? Continuously measuring these changes, tracking the ebb and flow of AI's capabilities against human work, will be absolutely crucial to fully understanding its long-term dynamic impact.
This truly raises an important and perhaps a slightly daunting but ultimately empowering question for you, our listener. Given everything we've discussed today, how will your work specifically change and evolve in the coming years? And perhaps even more importantly, what entirely new and unforeseen opportunities might emerge for you to focus on, allowing you to elevate your own unique contribution in this continuously evolving landscape of work. It's a question well worth pondering deeply as we move forward. Hashtag outro. We've unpacked an incredible amount today, delving deep into how generative AI is truly impacting the world of work. We move beyond theory and predictions, instead focusing on real-world user data gleaned from those 200,000 Microsoft Bing Copilot conversations.
Yeah, that real data makes such a difference.
We've seen how this technology is actively being used for everything from efficient information gathering and content creation to even surprising areas like coaching and providing direct advice.
And, crucially, we've also understood that while AI's capabilities align strongly with knowledge work and communication-focused roles, its true economic impacts are far more complex and often unpredictable.
Like the ATM example.
Exactly. Frequently leading to surprising outcomes that go far beyond simplistic notions of wholesale automation. The distinct yet complementary nature of AI assisting a user versus AI performing an action itself is central to truly understanding this profound nuance.
So as you go about your week, we hope you'll carry this provocative thought with you. If AI can now successfully assist you with things like gathering information, writing and editing, and even stepping into roles to provide guidance and advice, what parts of your current work could be redefined?
And importantly,
And perhaps even more excitingly, what new, perhaps unforeseen, valuable tasks might emerge for you to focus on, allowing you to truly elevate your own unique contribution in this rapidly evolving landscape of work. We hope this deep dive provides you with the clarity and insights to navigate that future with confidence.